Okay, Atash, I'm glad you asked this question because it is a little bit of a tricky one because it goes kind of against common sense. Let's read the question first. It says when the speed of a car is u, the minimum distance over which it can be stopped is s. If the speed becomes nu, what is the minimum distance over which it can be stopped during the same time? Okay, and that's where the confusion arises because typically you would expect that acceleration remains the same of a car, yeah, or deceleration or braking power, which means that if you have a higher initial speed, you should take more time to stop, right? But in this case, you're being told that the time is the same. So therefore, acceleration itself has to change, yeah? And that's really what makes the problem tricky. So how would one go about it? Let's see one way of doing it. What I've got here is a velocity time graph, okay? On the y-axis you've got velocity, on the x-axis you've got time, okay? The blue line represents the first case. It starts with a velocity of u, and after time t it comes to a halt, yeah? So its velocity is 0 at the end of time t. The pink line represents the second case, when its starting velocity is nu, yeah? So u multiplied by some factor. In the same amount of time it has to come to a halt, so that becomes your line. Alright, now let's just label the points. Okay, let's call this O, let's call this A, let's call this B, let's call this C. So from our knowledge of calculus, yeah, we can say that distance covered, okay, during a certain time interval is really the area under the graph during that time interval. So if you take case 1, okay, case 1, the distance covered S1 is going to be area of triangle AOC. Yes? If you take case 2, yeah, that is the pink line, then S2, the distance covered, is going to be area under of triangle OBC. Okay, and what you've got to really do is compare these two areas, yeah, because they represent the distances, and see what the relationship is. This should help you solve the problem. Let me know if you still have trouble.